Hi guys, today we are going to talk about x-squared test for independence. Suppose that we have a sample of 200 students and we want to check at significance level A equals 1% if the results in physics and math tests are independent. So we have the following this table here. For physics, we have good, very good, excellent. For maths, good, very good, excellent. These are the observed frequencies. For example, excellent maths. For excellent maths, we have 60 out of 200 students. And for excellent physics, we have 50 out of 200 students. As I said earlier, these are the observed frequency. And the degrees of freedom for this table, as you probably know from theory, is rows minus 1 times columns minus 1, which is 3 minus 1 times 3 minus 1, which is 2 times 2 equals 4. So now we have the null hypothesis, our null hypothesis, which is H naught. The results are independent. This is our null hypothesis. And we also have H1, our alternative hypothesis, which is the results are not dependent. Now let's continue with our test. Well, we suppose that these results are independent, and we construct a table for the expected frequencies. How do we construct this table? Let's see. We multiply 60 by 50 and divide by 200 for cell 1, as these results are considered independent. Well, now we have 15 here. We will do the same for each cell. For this cell here, we have 60 times 100 over 200, which gives 30, etc. These are our expected frequencies, Fe. So, finally, we are going to use a formula for each cell. This is our formula. Observed frequency minus expected frequency, and the result raised to the power of 2 over expected frequency. This will be calculated for each cell. That is F naught minus Fe over Fe, F naught minus Fe raised to the power of 2. So, for example, for the top left cell, we have this here. 15 minus 10, or 10 minus 15, it's the same, raised to the power of 2 here, and divided by 15, which is our expected frequency, and this gives a result 1.666. Well, we'll do this for every cell, for all cells. This is our final step. Now, if we add all these results for 9 cells, we'll do this for every cell, and if we add all this, it gives x squared equals 17.5. This is our calculated x squared. Now let's go to the final step. The final step is to find our critical value. Now, how do we find our critical value? We can use this formula. As this formula is rather complicated, just forget it. You can use your calculator or a table, and from this table or from your scientific calculator, you can get this critical value for n equals 4 degrees of freedom and A equals 1% significant level. We have x squared 13.28. Since our calculated x squared here is greater than this, H naught is rejected. So we reject our null hypothesis. Thank you for watching this video.